Okay, look at this question we have here. A car of mass 500 kg moving with a forward acceleration of 6 meters per second squared is acted upon by a constant resisting force of 800 Newton. Calculate the force exerted by the engine to maintain its forward acceleration. Okay, so now as you can see, a car, this is the mass of the car. It is moving with acceleration of this. Okay, it's acted upon by a constant resisting force of 800 Newton. Calculate the force exerted by the engine to maintain its forward acceleration. So let us take that this is a car. And this car, let's assume, like they said there, it is traveling at 6 meters per second squared. This is the acceleration. And as the car is coming, it now hits a load, it now hits something, and the weight of this load is 800 Newton. You know, if a car is coming with a speed and hits something, definitely the speed of the car will be reduced. Okay, but here they are telling us that we should calculate the force the engine of this car will produce such that when it hits this very load, the speed will not reduce, it will still maintain that same speed. Okay, so this is our acceleration. So this is the acceleration at which the car is moving. So we are looking for the force the engine of this car will generate so that when it hits this, it will still maintain the acceleration of 6 meters per second squared. So on that note, since this car is the mass of this car, okay, mass of the car is equal to 500 kg, okay, and it is moving with acceleration of this. So the car is moving with acceleration equal to 6 meters per second squared. Okay, so if you check now the weight of this car, if at all I want to calculate the weight of this car, you know, weight has something to do with a force. The weight of this car, okay, let's say force on the car as the engine is working is equal to mass of the car times its what? Acceleration. So this is the force the engine is producing to move the car. So the force will now be equal to, our mass is 500 kg, 500 kg times what is the acceleration of the car? 6 meters per second squared. This will now be equal to 500 times 6 will give us 3000 Newton. So for this car to be moving at this speed, where this is the mass of the car, it means that the engine is producing a total force of 300 Newton. Now, we are now asked that what will be the weight or what will be the force the engine have to produce so that when this car hits this object, it will not reduce its speed and its acceleration, that it will maintain the same acceleration. So for this car to maintain the same acceleration, it means that the engine will produce a force that is equivalent to 300 Newton and at the same time the force that is equivalent to 800 Newton, such that when it hits this, it will not look as if it hits something, it will keep on going. So the total force, that is the net force the engine will produce will be the force the engine produced to move the car at this rate, which is 3000 Newton, plus the force of the resisting material, that is 800 Newton, which will give us 3800 Newton. Okay, a car of mass 500 kg moving with a forward acceleration of this is acted upon by a constant resisting force of this. Calculate the force exerted by the engine to maintain its forward acceleration so that the acceleration is kept constant, it didn't change. So for the car to be moving, this is the mass of the car, this is the acceleration at which the car is moving. It means that the force the engine is producing to move the car is 3000 Newton. Now, since it will hit an object, we know that if a car should hit an object, it means that the speed will do what? Reduce. When the speed reduces, it means that acceleration has also reduced. But we want this car to hit this thing and keep maintaining the same speed. It means that the force the engine will produce will be the force it produced to move this car at this rate plus the force of the material. So when it hits this, it will look as if it never hit anything. It will keep maintaining the speed. So our answer is 3,800 Newton, which is option B.